Looking farther into IXL, I found some problems where they don't tell you the X, the Y, or the Z, so you don't have a number to begin with. So I wanted to go through one of these so you could see how that might work also. Right here, you know that y equals x minus 13. So this is one thing that I can replace into my other two equations. You're always looking for something to do that'll make them easier. So this middle equation right here, I can rewrite as negative 5x minus 5, and then where there was a y, I'm going to replace or substitute in x minus 13. Then I'm going to keep going with this equation, which is plus 3z equals 13. So if I distribute, I'll have negative 5x. This will turn into negative 5x. This will actually turn positive, and then that'll turn into a positive 65. And then plus 3z equals 13. Okay, so I can collect some like terms, and these do not cancel out. They are going to actually turn into a negative 10. I'm going to keep the 3z because it's a variable, but I'm going to move this over by subtraction. So if I take 13 and I subtract 65, I'm going to land at a negative 52. So right now I'm stuck, but I have gotten rid of one variable and I just have x's and z's left, and I've used this one. In the last one thing that I see is that they all have 6 the whole way through. So I could divide out a 6 of this problem and really not change the problem mathematically because I'm doing the same thing to every part. So if I divided every single piece of this by 6, you don't have to do this, it's just something I'm seeing that's going to make that last one easier to work with. It would just be a negative 1x, a negative 1y, a positive 1z equals 1. All I did was divide that 6 out of each of those pieces. But I also know from the top that negative y, the y part can be replaced with x minus 13. Then I still have plus z equals 1. So distributing this negative, I'll have negative x minus x plus 13 because those negatives would cancel, and then plus z equals 1. These two go together to be a negative 2x plus 1z, and this 13 I would move over by subtraction, just like we did over here with the 65. So then I would have that negative 2x from these two plus z equals negative 12. All right, so we are one step closer. Now we have to substitute. These look messy. Here, looking to get something alone, this looks like the easiest thing to get alone because I can get that alone by adding this 2x to the other side. And if I move that over by adding 2x here and adding it to this side, now I know that z equals negative 12 plus 2x. So I'm getting closer because now this can go back in to this equation and help me get rid of that last variable. So negative 10x plus 3 times z, except for z is now negative 12 plus 2x. Because keep in mind, our goal is to get just one variable that we know how to solve for. So here I got this alone, so now I'm able to just put this in here for the z, and now this whole equation is just x's. So I'll distribute my 3, get negative 36 plus 6x. This negative 10x and a positive 6x will be a negative 4x. And then I'm going to add this 36 over to the other side so that I can have just my negative 4x equals negative 52 plus 36. So that side will become a negative 16. And now finally the pieces are going to start to fall into place because when I divide by negative 4, I finally find out that x is 4. But the rest will go pretty quickly. Once I know one of these, I just look back through my work. So it's nice if your work is kind of neat and clean. And I can say, okay, x is 4. Great. But look up here, look around and find like the next thing that you can do easily. Y is related to x because y is going to equal your x, which we just decided was 4, minus 13. And so then I can plug it in anywhere, but I want to plug it in where I can have an easy answer. And so then my y is going to be negative 9. And then I need to search around and find, how do I get z? Well, z was alone over here. Anytime you have like the y equals or the z equals, those are the ones you want to be plugging stuff back into, not these messy ones. So z is going to equal negative 12 plus 2 times x, but I know that x is 4. So that's going to be negative 12 plus 8. So my z value is going to be negative 4. So that's no joke. That takes me a long time to do that. So what I want to do before I enter it back in to see if it's right is go ahead and test it out. So in this first equation, y, which is negative 9, should equal my x, 4 minus 13. Sure does. So I know that my answers work for this. Here, when I want to go through and test this one, I'm going to have my negative 5. I'm going to multiply that by my x value of 4. Then I'm going to take away 5 times my y value of negative 9. Then I'm going to add 3 times my z value of negative 4. And when I'm done, I get 13. So that checks, and I know that all works out. Then in the last equation, I either can use the original or I can use the one that I divided, but say that I use the original. I'd have negative 6 times my x value of 4 minus 6 times my my y value of negative 9 plus 6 times my z value of negative 4, and that comes out to be 6, which is awesome because that's what this is telling me it should come out to equal. So then I can go back to my homework and enter those 3 values in, confident that they will be correct. So hopefully that helps. Bye, guys.